Hi there, students. In this video, I'm going to show you where trigonometric ratios come from. As you can see, we have three right triangles. These three right triangles have different side lengths. What these three right triangles do have in common are the angles. All three right triangles have a 30-degree angle, a 90-degree angle, and using the property that all three angles have to add up to 180, the third angle, even though it's not labeled, must equal 60. So all three triangles have congruent angles, or equal angles. What is different about all three triangles is the lengths of the sides. Whenever angles are equal, but the side lengths are different, we want to check to see if the sides might have some common properties, such as being proportional. Sides are proportional when they grow or decrease by the same factor. What I mean by that is, let's say you have a triangle that is 2, 4. And then you make a bigger triangle that is 4, 8. As you can see, each side got 2 times bigger. This would be an example of proportional. It's like taking a picture, right? And you take the picture to the shop to get bigger. If you have a picture and you make it only longer, the person's gonna come out really long and the picture's gonna be distorted. So whenever you want something to be proportional, you have to make it grow by equal factors. So if I'm gonna make it longer, then I also have to make it a little bit wider so that the picture looks the same. That's what proportional means. So we wanna check, okay, these triangles have equal angles, but are the sides proportional? So we're going to divide some sides to see if they're proportional. So let's look at the violet triangle. We're going to divide from this violet triangle. We're going to divide the opposite side by the hypotenuse. So 5.8 divided by 11.5 and see what we get. 5.8 divided by 11.5, 0.50. And then let's go to the blue triangle and also divide the opposite side by the hypotenuse. 4.5 divided by 9, 0.50. And then the green triangle, we're going to divide the opposite side, 7.1 divided by the hypotenuse, 14.2. And we also get 0.5. So those ratios are equal. Let's check the other ones. Let's go back to the violet triangle and divide adjacent, which is 10, divided by hypotenuse, 11.5. 10 divided by 11.5, 0.87. Go ahead and pause the video and try the rest yourself. Okay? Once you press play, you should have noticed that we also get 0.87 for these two. And for the last triangle, you get 0.58 for all three. Because we get the same number, we can see that these three triangles are proportional, because they have equal ratios. So the sides are proportional. The angles are equal or congruent. Because the angles are congruent and the sides are proportional, that means that these three triangles are similar. In fact, all right triangles that have the same angles are similar. Because the triangles share this property and are all similar, these ratios can be used to find missing side lengths. Because these ratios are always equal, mathematicians gave these ratios special names. The first one is called sine, opposite divided by hypotenuse. The second one is called cosine, and they're in your calculator. The third one is called tangent, opposite divided by adjacent. Now, these triangles were already labeled for us. However, when you get a triangle that is not labeled, it is very important to label it correctly. You always want to label your right triangle before working with it to avoid any careless mistakes. So, when you have a triangle, you first have to make sure you know what angle you're going to be working with. You always work with one of the acute angles, A or B. So, let's say we want to work with angle A. We're going to go across angle A. So this is angle A right here. We're going to go across. That side is called opposite. We can abbreviate it OPP. This side across the 90-degree angle is always called hypotenuse. We can abbreviate it HYP. And whatever's left is adjacent. I like to label adjacent last so that I don't get it confused. Okay? But let's say we were working with angle B instead. If we work with angle B, then across angle B, now this would be opposite. Across the 90 is still hypotenuse, and whatever's left is adjacent. We label it ADJ. It's called adjacent. The word adjacent means next to, so this side is next to the angle. Okay? I'm going to draw one and have you pause the video and try labeling it yourself. We're going to work with angle A. You should have gotten this one's opposite. That means BC is opposite. Across the 90 is hypotenuse, and whatever's left is adjacent. Now, the formula for the sine of an angle, sine of theta, this is a Greek symbol called theta, and it stands for angle. Sine is always opposite divided by hypotenuse. Cosine of theta is always adjacent divided by hypotenuse. And the tangent of theta is always opposite divided by adjacent. These formulas are on your formula sheet for the EOC. However, when working with them in class, it's useful to use the following acronym, SOHCA TOA. That helps you remember that sine is equal to opposite over hypotenuse, cosine is equal to adjacent divided by hypotenuse, and tangent is divided by opposite over adjacent. That's what those letters stand for. So when you want to form ratios, let's say you have a triangle and the sides are 3, 4, and 5. And let's say your side length, your corners are called A, B, and C. If we want to find the sine of C, we go to angle C, we go across, that's called opposite. You go across the 90 degree, that's called hypotenuse, and whatever's left is called adjacent. If we want to find the sine, we need OH, opposite over hypotenuse. So then that means that the sine of C is equal to 3 over 5. Okay, the cosine of C is equal to adjacent over hypotenuse. That is 4 over 5. And the tangent of C is opposite over adjacent, 3 over 4. Now let's work with angle A instead. What if I want to find the sine of angle A, the cosine of angle A, and the tangent of angle A? Because we're working with a different angle, opposite is going to change and adjacent is going to change. So whenever you switch the angle, you have to be careful. So now across angle A, now this one is opposite. The hypotenuse is still across the 90, and the adjacent is now side AB. So now the sine is opposite over hypotenuse, 4 over 5. The cosine is 3 over 5. And the tangent is opposite over adjacent, 4 over 3. Notice both of these equal 3 over 5. So the cosine, that's an important property. The cosine of one of the acute angles is always equal to the sine of the other angle. We can use actual angle measurements. The cosine of 30 degrees, for example, is always equal to the sine of 60 degrees. These two angles have to add up to 90. That's an extra property that's on your EOC. The important part here is setting up your ratios correctly. In the next video, I'll show you how to find the missing side or the missing angle using trigonometry. Hope this helps.